Integration by itself is a quite difficult concept to understand and solve. Solving trigonometry under integration is still a nightmare for many. How about we change that today? With the help of our 3 mantras of integration and few trigonometric formula, let's break this trigonometry and integration phobia. Before using mantras in the question, we will go through integration of common trigonometric function. What is integration of sin x and cos x? To answer this question, we need to think in terms of antiderivative. Which function d over dx will result in sin x? We all know the answer for this, that is minus cos x. So integration of sin x into dx will be minus cos x plus c. Which function d over dx will give us cos x? We even know answer for this, that is sin x. So integration of cos x into dx is sin x plus c. Naturally, we will think what is integration of tan x into dx. Let's keep the thought aside and we will think d over dx of tan x. That is secant square x. So integration of secant square x into dx is tan x plus c. And also let's differentiate secant x. So differentiation of secant x is secant x into tan x. So integration of secant x into tan x is secant x plus c. So in the same way, if we differentiate cot x and cosecant x, we will get the answer as minus cosecant square x and minus cosecant x and cot x. So integration of minus cosecant square x is nothing but minus cot x plus c, and integration of cosecant x into cot x is minus cosecant x plus c. Mantra 1 split. Let's start our first example. Integration of sin square x minus cos square x over sin square x into cos square x into dx. We will try our first mantra, that is split. We will split denominator to each term of the numerator. So we will get integration of sin square x over sin square x into cos square x minus cos square x over sin square x into cos square x into dx. Now we can cancel sin square x and cos square x in both numerator and denominator in term 1 and term 2 respectively. And we know 1 over cos square x is secant square x and 1 over sin square x is cosecant square x. So we are left with integration of secant square x minus cosecant square x into dx. We can use linearity property, which states we can integrate each term and add them up. So we can write integration of secant square x into dx minus integration of cosecant square x into dx. We know integration of secant square x is tan x and integration of cosecant square x is minus cot x. So we are left with tan x plus cot x plus c. Let's move to the next example. Integration a minus b sin x over cos square x into dx. We will try our mantra 1, that is split. So integration of a over cos square x minus b sin x over cos square x into dx. Next, we know 1 over cos square x is secant square x and sin over cos x is tan x. So we can rearrange as integration of a into secant square x minus b tan x into sec x into dx. We will integrate each term separately and add them up. So integration of a into secant square x into dx minus integration of b into tan x into secant x into dx. We know a and b are constant. So in the first term, a is a constant, we can take it out of integration. So integration of secant square x into dx we know as tan x. And in the second term, b is a number, we can take b outside. Integration of tan x into secant x into dx is secant x. So we are finally left with a tan x minus b secant x plus c. Mantra 2, create and split. We will take our first example on this mantra. Integration 1 over sin square x into cos square x into dx. Can we split? No, we can't, because there is only one term in the numerator. So we will use our second mantra, that is create and split. First, let's create. We can replace 1 with sin square x plus cos square x. So we are left with integration of sin square x plus cos square x over sin square x into cos square x into dx. Now we have two terms in the numerator, we can split now. So integration of sin square x over sin square x into cos square x plus cos square x over sin square x into cos square x into dx. We can cancel sin square x and cos square x in both numerator and denominator in each term, and also we can rearrange 1 over cos square x as secant square x and 1 over sin square x as cosecant square x. So we are left with integration of secant square x into dx plus integration of cosecant square x into dx. We know integration of secant square x into dx is tan x and integration of cosecant square x is minus cot x plus c. Let's move to the next example. Integration of sin square x into dx. Here we need to use create and split. Wherever we find sin square x or cos square x, always use God formula. Sin square x is equal to 1 minus cos 2x over 2. Do you know what is cos square x? Comment below. So we will replace sin square x with 1 minus cos 2x over 2 in the question. Now we can split. So integration of 1 over 2 minus cos 2x over 2 into dx. We can use linearity property, so we can integrate each term. So integration of 1 over 2 into dx minus integration of cos 2x over 2 into dx. So first term, 1 by 2 is a number, so we can take number outside. So we are left with 1 over 2 integration of 1 into dx. We know integration of 1 into dx is x. In the second term, again 1 over 2 is a number, we can take 1 over 2 outside. So we are left with integration of cos 2x. In another video, we will explain integration of cos 2x. For now, just remember this formula. Integration of cos ax is sin ax over a plus c. So integration of cos 2x will be sin 2x over 2 plus c. So we are finally left with 1 over 2x minus 1 over 2 into sin 2x over 2 plus c. Let's move to our next question. Integration of 1 over secant square x into tan square x into dx. Can we split? No, we can't, because there is only one term in the numerator. We'll try our second mantra. So let's create and split. We know secant square x minus tan square x is equal to 1. So we'll replace 1 by secant square x minus tan square x in the question. Now we have two terms in the numerator, so we can split. Integration of secant square x over secant square x into tan square x minus tan square x over secant square x minus tan square x into dx. We can cancel secant square x and tan square x in both numerator and denominator in each term. We can rearrange and write 1 over tan square x as cot square x and 1 over secant square x as cos square x. We will use linearity property. Integration of cot square x into dx minus integration of cos square x into dx. We know cosecant square x minus cot square x equal to 1. So cot square x we can replace with cosecant square x minus 1. In the second term we have cos square x. So we'll use our God formula. Cos square x is nothing but 1 plus cos 2x over 2. We'll replace all these formula into the last step. So we'll get integration of cosecant square x minus 1 into dx minus integration of 1 plus cos 2x over 2 into dx. Now we will use linearity property and split the second term. Integration of cosecant square x dx minus integration of 1 into dx minus half into integration of 1 into dx minus half into integration of cos 2x into dx. We know integration of cosecant square x into dx is minus cot x and integration of 1 into dx is x, and 1 by 2 integration of 1 into dx is half into x, and 1 by 2 integration of cos 2x into dx is 1 over 2 sin 2x over 2 plus c. Mantra 3. Derivative of denominator in numerator. The formula for this mantra is integration of f dash of x into dx over f of x is equal to log of f of x plus c. Let's move to the first question. Integration of cot x into dx. We know cot x is equal to cos x by sin x. So we'll replace that in question. integration of cos x over sin x into dx. Here we can't use our first mantra and we can't use our second mantra. So we'll go to third mantra. We will differentiate the denominator, that is d over dx of sin x. We will get it as cos x. So d by dx of denominator is numerator here. So we can use our mantra 3 formula. Integration of f dash of x over f of x into dx is equal to log of mod f of x plus c. So the denominator sin x, the differentiation is cos x into dx, it is in numerator. So answer for this is log of sin x plus c. Next question, integration of tan x into dx. We know tan x is sin x over cos x. So the question becomes integration of sin x over cos x into dx. Here we can't use our mantra 1 split and even we can't use our mantra 2 create and split. So we'll use our mantra 3. So let's differentiate the denominator. D over dx of denominator, that is d by dx of cos x is minus sin x. We will multiply minus 1 on both numerator and denominator. Now d over dx of denominator is in numerator. So we can use our mantra 3, integration of f dash of x into dx over f of x is equal to log f of x plus c. So answer for this question becomes minus log of mod cos x plus c. Let's move to the next example, integration of secant x into dx. At this point, we only know integration of secant square x into dx, that is tan x plus c. So let's find out what is integration of secant x into dx. To solve this, we need to multiply secant x plus tan x on both numerator and denominator. Now we'll multiply secant x in the numerator, so we will get secant square x plus secant x into tan x over secant x plus tan x. Now let's use our mantra 3, that is differentiating denominator and checking the numerator. So let's differentiate denominator, d by dx of denominator, that is equal to d over dx of secant x plus tan x. So differentiation of secant x is secant x tan x plus tan x differentiation is secant square x. So differentiation of denominator is numerator. So we can use the formula of mantra 3, that is integration of f dash of x into dx over f of x is equal to log mod f of x plus c. So here the denominator is secant x plus tan x. So the solution for this question will be log mod secant x plus tan x plus c. Next question, integration of cos x over 1 plus sin x into dx. We can't use our mantra 1 and also we can't use our mantra 2. So we'll try our mantra 3 here. D over dx of denominator, so d over dx of 1 plus sin x, that is 0 plus cos x. Now we can see differentiation of denominator is numerator. So we can use a formula integration of f dash of x into dx over f of x is equal to log mod f of x. So the solution for this question would be log mod 1 plus sin x plus c. Next question, integration of sin 2x over 1 plus sin square x into dx. We can't use our mantra 1 and also we can't use our mantra 2. So let's try our mantra 3. D over dx of 1 plus sin square x is, differentiation of 1 is 0 and sin square x differentiation is 2 sin x and sin x differentiation is cos x. So 2 sin x into cos x is differentiation of 1 plus sin square x. Here d over dx of denominator is not numerator, so we can't use our mantra 3. So let's try our trigonometric formulas in the numerator. Sin 2x is 2 sin x and cos x. So we'll replace sin 2x in the question by 2 sin x and cos x. So we have here integration of 2 sin x cos x over 1 plus sin square x. Yes, now differentiation of denominator is numerator. So we can use our mantra 3 formula, integration of f dash of x into dx over f of x is equal to log mod f of x plus c. The solution for this question will be log mod 1 plus sin square x plus c. At this point, we know integration of cosecant square x, that is minus cot x plus c. To find this, we need to multiply cosecant x plus cot x in both numerator and denominator. So we'll get integration of cosecant x into cosecant x plus cot x over cosecant x plus cot x. Now we'll multiply cosecant x, we'll get integration of cosecant square x plus cosecant x into cot x over cosecant x plus cot x into dx. Now we'll try our mantra 3, that is differentiating denominator. So d over dx of cosecant x plus cot x will be, cosecant x differentiation is minus cosecant x into cot x and cot x differentiation is minus cosecant square x. Now denominator differentiation is not equal to numerator. So let's take minus common in the numerator. So minus integration of minus cosecant square x minus cosecant x into cot x over cosecant x plus cot x into dx. Now we can see differentiation of denominator is in the numerator. So we can use our mantra 3, that is integration of f dash of x into dx over f of x is equal to log mod f of x plus c. So the solution will be minus log mod cosecant x plus cot x plus c. Hope you got over your phobia with the help of 3 mantras of integration. Like, share and subscribe to our channel for more such mantras. Let us know in the comment below on what concept should our next video be. And this was integration mantra for trigonometric function.